Congratulations on successfully downloading the Distance Learning Day presentation. We're going to talk about topographic maps today, guys. If you want to kind of follow along in your book, that's fine, but there's plenty of things to keep your attention here. This image is an example of a topographic map. Remember, topography is the shape of the land, so a topographic map shows just that, the shape of the land. This particular topographic map uses color to show elevation. The areas that are in red are the highest, and the areas that are in blue or purple are the deepest. Notice you can see the highest parts are in the Rocky Mountains and the Andes Mountains in South America. The deepest parts are in the ocean, but also notice you can see the mid-ocean trench rising up from the sea floor, just a little bit higher elevation than the rest. Most actual topographic maps, however, don't use color to show the topography. They use contour lines. Contour lines are lines on a map that connect levels of equal elevation. Let me show you what I mean. There, that's a better example of a topographic map. Oh, I'm sorry, did we go a little too fast? That's pretty confusing. Let's back up a second and explain this a little better. Alright, here at the top we see a topographic map depicting two hills. You can see the cross-section of the hills at the bottom, Able Hill and Baker Hill. What you're seeing here is each contour line representing a specific level of elevation. So when we reach the 10-meter mark on both Able Hill and Baker Hill, there's a line that travels around both on the topographic map. Hills are often shown this way as a series of circles getting smaller inside each other. You'd never see two contour lines crossing each other because that would mean that you have two levels of elevation at the same point, and that just doesn't really happen. We can also get a sense on this particular map of what we call the contour interval. The contour interval is the difference in elevation from one contour line to the next. Now this one's easy to find. I'm going from 10 meters to 20 meters to 30 to 40 to 50, and that's as high as Baker Hill goes, so that's where we stop. The difference between each of those lines is 10 meters, and so that's our contour interval, 10 meters. Here we see another version showing us the topographic map on top and the actual topography of the land, or a picture of the land, underneath. You can see here we have a nice mountain. If you look up, you can see the contour lines following the outline of the mountain up and up and up. In addition, on this topographic map, you may notice that a few of the lines seem darker than the others. Those are what we call index contours. On some topographic maps, but not all, we see darker contour lines. On topographic maps that have lots of contour lines, they go ahead and put index contours every 5, sometimes 10 or 20 lines, and these are the only ones that are labeled. Watch as this topographic map rotates in this short video segment. You'll see that on this map, both contour lines and color are used to show elevation. As it tilts back and forth, you can get a sense of what the hill that's pictured here actually looks like. Remember that contour lines connect points of equal elevation. Looking at a key of any map is important, but let's take a look at this particular key of commonly used map symbols for topographic maps. Some of them are very similar. Highways, secondary highways, railroad tracks, rivers, all that kind of stuff. But take a look at contour lines showing elevation and depression. We've already discussed that when you see a smaller and smaller and smaller circles going inward, that's going to be a hill. But take a look. Sometimes we get a depression, like a volcanic crater, or any depression on a hill or a mountain. Then, as they go down in elevation, you draw small lines on the inside so that people know the difference. Take a look at the topographic map on the next slide here in just a moment. I want you to think about the three types of landforms we discussed in class: plateaus, mountains, and plains. Look at the topographic map and see if you can tell, is this a mountain, a plateau, or a plain? So, what do you think this is? A mountain, a plain, or a plateau? If you guess plateau, you are absolutely correct. Again, this shows both contour lines and actual shading. But take a look. We have multiple contour lines getting smaller and smaller and smaller, which tells us that we're going up in elevation. But then we have this nice flat top. That's going to go ahead and be a plateau. Notice that towards the edges of the map, we see the contour lines more spaced out. What that tells us is that that area is gently sloping, as opposed to near the center of the map where we get very closely linked contour lines. That's going to go ahead and mean that's a very steep slope. Do notice also that we have index contours on this particular map, which are those darkened, labeled contour lines that go every 5-10 lines or so. Altogether, this is a great example of a topographic map. Well, that concludes what we're talking about with topographic maps today. For the next part, you're going to use the last figure available in this movie. It'll pop up here just in a second. You can hit pause, then open the online assessment and follow the directions to answer the questions. You can also look in your book on page 29 at the math analyzing data. It's the same figure. All right, guys, have a good afternoon, and we'll see you tomorrow.